Hello students, welcome to my YouTube channel and welcome to a new video session. In this particular video session, just we are going to discuss about the short type questions from the topic vector of your last 10 year CHSE annual exam. That means from the year 2013 to the year 2023 CHSE annual exam. And here we are going to discuss about the short type questions. That means the questions carrying 3 marks or 4 marks. So these are the questions we are going to discuss in this video session, and they are from the topic vector and the last 10-year questions from the CHSE annual exam 2013 up to 2023. So let us start the video from the first question. So here it is the first question. And the question number 1 from the year 2023, prove that two vectors A vector and B vector are perpendicular if and only if the square of magnitude of the sum of A vector and B vector is equal to the square of magnitude of A vector added with the square of magnitude of B vector. So first of all, we have to see that we have to prove this problem from both sides, from left hand side to right hand side data and from right hand side to left hand side data. And here it is the left hand side data. Two vectors A vector and B vector are perpendicular. Here it is the left side data and here it is the right side data. This condition is the right hand side data. So first of all, in case number 1, we have to prove this problem from left side to right side, and in case number 2, we have to prove it from right side to left side. So here it is the case 1. Given that A vector is perpendicular to B vector, that is A vector dot B vector is equal to 0. So it is the given condition. This is the given condition. We have to prove this. Then here applying the properties of dot product, we can have it is A vector multiplied with A vector plus A vector multiplied with B vector plus B vector dot A vector plus B vector dot B vector. A vector dot product with A vector, it is square of magnitude of A. Then it is A vector dot B vector is equal to 0. B vector dot A vector is also equal to 0 because we know that A vector dot B vector is equal to B vector dot A vector and commutative property satisfied in the dot product. So here it is 0, here it is 0 and it is so here it is the right hand side and the first case is proved. Here it is the first case. Then from the right hand side, we have to go to the left hand side. So let us prove the case number 2. Given that, okay, first of all write down, it is case number 2. Given that by cancelling the common parts from the both side, we have 2 into A vector dot B vector is equal to 0. So A vector dot B vector is equal to 0. That implies A vector is perpendicular to B vector. And here it is the proof of the case number 2. Then next, let us move to the question number 2 of the year 2023. Here it is the question number 2. Find the value of lambda so that the three vectors, this vector, and this vector are coplanar. Let a vector is equal to I cap plus 2j cap plus 3k cap. B vector is equal to 4i cap plus j cap plus lambda k cap. And C vector is equal to lambda I cap plus 4j cap plus k cap. It is given that the three vectors are coplanar. So we have to use the property of coplanar, that is 1, 2, 3, 4, 1, lambda 4, 1, and its determinant is equal to 0. We have to solve this determinant. By solving it, you have to solve it. You will get 2 lambda plus 11 into lambda minus 5 is equal to 0. You have to solve it. Then it will be 2 lambda plus 11 is equal to 0, or lambda minus 5 is equal to 0. That implies 2 lambda is equal to minus 11, or lambda is equal to 5. Here it is one of the value. That means lambda is equal to minus 11 divided by 2. So for lambda is equal to minus 11 by 2 and lambda is equal to 5, or lambda is equal to 5, the three vectors are coplanar. So here it is the proof. Just you have to solve the determinant here in 2 steps, and then rest of the answer will be this. Then next, moving towards to the next question. Then here it is the third question of the year 2023. We know that a vector dot b vector is equal to magnitude of a vector multiplied with magnitude of b vector with cos theta. The whole square of dot product of a vector and b vector, it is a square b square cos square theta. Again, we know that the cross product of a vector and b vector is a square b square sin square theta. Now putting these values here, we have a square b square sin square theta plus a square b square cos square theta. Then taking a square b square as a common, we have in the bracket sin square theta plus cos square theta. Then it will be a square b square dot 1, or sin square theta plus cos square theta, it is 1, so no need to multiply it here with a square b square. So the results are here what we have just got here, the square of cross product of a vector and b vector added with square of dot product of a vector and b vector equals a square b square. So just taking this value towards the right hand side, we have the solution here or answer. Here is the answer for the required question. So here it is the question number 3 or third question from the year 2023 annual exams. Then moving towards to the year 2022. Here it is the question from the year 2022. It is given that if the position vectors of the points P, Q, R, S are this much respectively, then so that we have to prove that these two vectors are parallel with each other. Given that position vector of P is equal to 4i cap plus 3j cap minus k cap. Position vector of Q, it is 5i cap plus 2j cap plus 2k cap. Position vector of R, it is 4i cap minus 4j cap plus 3k cap. Okay, position vector of R, it is 2i cap minus 2j cap minus 3k cap. Position vector of S, it is 4i cap minus 4j cap plus 3k cap. So first of all, we have to find out PQ vector. It is position vector of Q minus position vector of P. Position vector of Q, it is 5i cap plus 2j cap plus 2k cap minus position vector of P, 4i cap plus 3j cap minus k cap. Then here we will get 5i cap plus 2j cap plus 2k cap minus 4i cap minus 3j cap plus k cap. Then simplifying, we have PQ vector is equal to 5i cap minus 4i cap, it is I cap. Then 2j cap minus 3j cap, it is minus j cap. 2k cap plus k cap, it is 3k cap. So here it is the PQ vector. Then RS vector. Position vector of S minus position vector of R. Position vector of S, here it is 4i cap minus 4j cap plus 3k cap minus position vector of R, 2i cap minus 2j cap minus 3k cap. 4i cap minus 4j cap plus 3k cap minus 2i cap plus 2j cap plus 3k cap. It is 2i cap minus 2j cap plus 6k cap. Taking 2 as common here it is the RS vector. Taking 2 as common, we have I cap minus j cap plus 3k cap. So it will be RS vector is equal to 2 into, in place of I cap minus j cap plus 3k cap, we can put PQ vector, 2 into PQ vector. So here you can see that in this step, one vector is scalar multiple of another vector. So both of the vectors are parallel with each other. So PQ vector and RS vector are parallel. And here it is the proof of the question. Then next moving towards to the next question. Here it is the next question. If the 4 points with position vectors this much and this much are coplanar. So we have to start from, given that, or you can say that let position vector of A 2a vector plus 3b vector minus c vector. position vector of B, A vector minus 2B vector plus 3C vector. Position vector of C, 3A vector plus 4B vector minus 2C vector. And position vector of D, A vector minus 6B vector plus 6C vector. So here we have to find out, first of all we have to find out AB vector, that means position vector of position vector of B minus position vector of A. Position vector of B, it is A vector minus 2B vector plus 3C vector minus 2A vector plus 3B vector minus C vector. Then this will be minus A vector minus 5B vector plus 4C vector. This is AB vector. Similarly, a C vector, it is position vector of C minus position vector of A. Position vector of C, it is 3A vector plus 4B vector minus 2C vector minus position vector of A, it is 2A vector plus 3B vector minus C vector. So it will be A vector plus B vector minus C vector, and this is AC vector. Then AD vector, it is position vector of D minus position vector of A, and this will be position vector of D, it is A vector minus 6B vector plus 6C vector minus A vector, it is 2A vector plus 3B vector minus C vector. So it will be, AD vector will be minus A vector minus 9B vector plus 7C vector. So here these are the three equal vectors, AB vector, AC vector and AD vector. AB vector dot product with the cross product of AC vector and AD vector. So it will be minus 1, minus 5, 4, 1, 1, minus 1, then minus 1, minus 9, plus 7. Simplifying this, we can have 1 minus 1, minus 9, 7, minus minus 5, 1 minus 1, minus 1, 7, plus 4 multiplied with 1, 1, minus 1, minus 9. This is minus 1 multiplied with 7, minus 9, plus 5 into 7, minus 1, plus 4 into minus 9, plus 1, then it will be minus 1 multiplied with minus 2, plus 5 multiplied with 6, plus 4 multiplied with minus 8, then it will be 2, plus 30, minus 32, then it will be equal to 0. So, the 4 points are coplanar. Then let us go through the next question. Then here it is the next question. Given that A vector is equal to 3i cap plus j cap plus 2k cap and B vector is equal to 2i cap minus 3j cap plus 4k cap. We have to verify that A vector cross B vector is perpendicular to both A vector and B vector. That means we have to prove that A vector cross B vector dot product with A vector is equal to 0, and also the cross product of A vector and B vector dot product with B vector is also equal to 0. We have to prove these two conditions. But before this, first of all, we have to find out A vector cross B vector. A vector cross B vector, it is I cap, j cap, k cap. 3, 1, 2, it is 2, minus 3, 4. You have to solve this. 1, 2, minus 3, 4, minus j cap, you multiplied with 3, 2, 2, 4, plus k cap multiplied with 3, 1, 2, minus 3. You have to solve this. Then you will get the result 10 I cap minus 8 j cap minus 11 k cap. Then it is the, here it is the A cap cross, sorry, A vector cross product with B vector. Then we have to find out that means A vector cross B vector 10 I cap minus 8 j cap minus 11 k cap dot product with A vector is 3 I cap plus j cap plus 2 k cap, and it will be equal to 10 into 3, it is 30. Just we have to multiply the coefficients of the same unit vector. 10 into 3, 30, minus 8 into 1, 8, minus 11 into 2, minus 22, it is 0. So, A vector cross B vector is perpendicular to A vector. Then, A vector cross B vector multiplied with B vector, that means A vector cross B vector, it is 10 I cap minus 8 j cap minus 11 k cap dot product with B vector 2 I cap minus 3 j cap plus 4 k cap. It will be 10 into 2, 20, minus 8 minus 3, it will be plus 24, minus 11 into plus 4, it is minus 44, it is 0. So, it is also proved that A vector cross B vector is perpendicular to B vector, and here it is the proof of the given question. Just you have to solve this step here. Two or three steps will be there. You have to solve it. Then moving towards to the next question. Here it is the next question. Find a unity vector perpendicular to each of the vectors, A vector plus B vector and A vector minus B vector, where the two vectors are given to you, A vector and B vector. So first of all, we have to write down what are the given data here. Given that A vector is equal to this much and B vector is equal to this much. Then we have to find out A vector plus B vector and A vector minus B vector. Just I have left the steps. Directly I have written because I have already solved this problem. So you have to solve this step by step. You have to write down A vector, then plus sign, then B vector, then you have to write down this step. So I have skipped some steps here. A vector plus B vector, here it is, and the value of A vector minus B vector, it is minus j cap minus 2 k cap. Then what to do? Just you have to find out the cross product of both these vectors. Then it will be I cap, j cap, k cap, it is 2, 3, 4, 0, minus 1, minus 2. And this will be, after solving 2 or 3 steps, you will find out it is minus 2 I cap plus 4 j cap minus 2 k cap. And here it is the value of, the cross product of A vector plus B vector and A vector minus B vector. And then you have to find out the magnitude of this obtained result. That means magnitude of the cross product of then you will get it as 2 root 6. Then the final step, the unit vector perpendicular to a vector plus b vector and a vector minus b vector is given by a vector plus b vector and its magnitude divided by the magnitude of the cross product of a vector plus b vector and a vector minus b vector. So it will be minus 2i cap plus 4j cap minus 2k cap whole divided by 2 root 6. Hence the result will be minus 1 by root 6 I cap plus 2 by root 6 j cap minus 1 by root 6 k cap, and here it is the answer. Then moving towards to the next question. Here it is the next question of the year 2019, and we have already discussed about it a little while ago, so no need to solve it again. So next moving towards to the year 2018. Then here it is the next question. Find the area of the triangle ABC with the vertices A1, 2, 4, V3, 1, 1, 2, C4, 3, 1 by the vector method. Position vector of A, it is I cap plus 2j cap plus 4k cap. Position vector of B, it is 3i cap plus j cap minus 2k cap. Position vector of C, it is 4i cap plus 3j cap plus k cap. Then you have to find out AB vector, position vector of B minus position vector of A. You have to solve it step by step. 3i cap plus j cap minus 2k cap minus I cap plus 2j cap plus 4k cap. Then it will be 3i cap plus j cap minus 2k cap minus I cap minus 2j cap minus 4k cap. It will be 2i cap minus j cap minus 6k cap, and here it is AB vector. Then you have to find out similarly, in similar pattern we have to find out AC vector. So AC vector, you have to you have to write down the steps. I have to write down directly the value. Position vector of C minus position vector of A, 4i cap minus I cap, it is 3i cap. It will be position vector of C minus position vector of A, 3i cap, then it is plus j cap, then it is minus 3k cap, and here it is AC vector. Then you have to find out AB vector cross AC vector, I cap, j cap, k cap. It is 2 minus 1 minus 6, it is 3, 1 minus 3, and then solving this step we have to find out the value, and the value is equal to 9i cap minus 12j cap plus 5k cap. You have to write down the steps here. 9i cap minus 12j cap plus 5k cap. Then magnitude of the cross product of AB vector and AC vector, it is root over of 250, that is equal to, okay, it will be square root of, then it will be square root of 250, that means 5 root 10. The area of the triangle, hence the last step is here. The area of the triangle ABC is half of magnitude of AB vector cross AC vector. It is half into 5 root 10 square unit. And here it is the answer. Then moving to the next question. So here it is the next question. Okay, from the left hand side we have to prove it from the left hand side. Then by applying the appropriate formula here, we have A vector plus B vector dot product with the cross product of A vector plus B vector. Then applying the cross product here, it is B vector cross C vector plus B vector cross A vector plus C vector cross C vector plus C vector cross A vector. The value of a C vector cross C vector, it is 0. So the remaining values are here. B vector cross C vector plus B vector cross A vector plus C vector cross A vector. Then by applying the dot product here, we have A vector dot product with B vector cross C vector plus A vector dot product with the cross product of B vector and A vector. Then A vector dot product with the cross product of C vector cross A vector plus B vector dot product with B vector cross C vector plus B vector dot product with B vector cross A vector plus B vector dot product with C vector cross A vector. Then the value of A vector dot product with B vector cross vector, it is 0, it is 0, it is 0 and it is 0. So the remaining terms are here A vector dot B vector cross C vector plus the last part is here B vector dot product with C vector cross A vector. It is none other than the and it is also hence which is the right hand side or the required solution, and it is the right hand side. Then moving to the next question. Here it is the next question. If the sum of two unit vectors is also a unit vector, then we have to prove that magnitude of their difference is root 3. And here it is the proof. Let A cap and B cap be any two unit vectors. It is also given that the sum of two unit vectors is also a unit vector. That is, the magnitude of A cap 1, magnitude of B cap 1 and the magnitude of A vector plus B vector is also equal to 1. As squaring both sides, we have then it is a cap plus b cap multiplied with a cap plus b cap, it is 1. Then it will be a cap multiplied with a cap plus b cap multiplied with a cap plus b cap, it is 1. Then it will be a cap dot a cap plus a cap dot b cap plus b cap dot a cap plus b cap dot b cap. It is 2 multiplied with a cap dot b cap plus magnitude of square of magnitude of b cap, it is 1. In place of square of magnitude of a cap, we can put here 1 plus 2 a cap b cap. Next moving towards, and here it is the value 2 a cap b cap, it is minus 1. Now whole square of magnitude of a cap minus b cap, it will be a cap minus b cap multiplied with a cap minus b cap, a cap multiplied with a cap minus b cap minus b cap multiplied with a cap minus b cap. It is a cap multiplied with a cap minus a cap multiplied with b cap minus b cap multiplied with a cap plus b cap multiplied with b cap. Then it will be magnitude of the square of magnitude of a cap minus b cap, it is in place of magnitude of a cap we can put 1 minus, in place of 2 a cap b cap we can put minus 1, in place of magnitude of b cap we can put 1. So it will be a cap minus b cap and its magnitude whole square, it is 1 1 1, it is 3. Then a magnitude of a cap minus b cap, it is root 3. So magnitude of their difference is root 3. So here it is all about today's video session, and in this particular video session just we have discussed about the questions from the year 2018 to 2023. And in the next part, that means in the part number 2 of the video, we are going to discuss about the problems based upon the short type questions from the year 2013 to the year 2017. Till the next video session, thank you.